So for today we are going to learn about the number 8. The first thing we want to look at is the first three multiples of 8, which are 8, 16, and 24. I want you to write these on your paper, and then we will keep going and figure out what the arrays are. The arrays for 8, since 8 is a prime number, which is not like 7, which is what we discussed about yesterday, it is actually going to be able to have a second array, unlike 7 did. So the first array that we can draw for 8 looks like this. And so there's 8 boxes, 1, 2, 3, 4, 5, 6, 7, 8. That's what an array of 8 looks like. Another way to draw an array of 8 is when you draw have it long. Oops. You're going to cut it in half, and then you're going to have four squares on the top and 4 squares on the bottom. When you do that, 4 on top, 4 on bottom, you take that times 2, which is 8, which is why this one works. And this one, since there's only one of it, it is 8 times 1, which is also 8. Take a quick look at this page right here. If you look at this first problem, you can see that it's been grouped in 2 different ways. I want to solve these problems real quick to determine if the way we group them with multiplication gives us a different answer. So when we do 8 times 2, 8 times 2 is 16, times 5, which is 80. This one, 2 times 5, we know is 10. Then we multiply it by 8, which is 80. Now a lot of you, when looking at this, can see that this one might be the easier way to get it because we know that anything times 10 is that number and then you add a 0 on the end of it. So that can be seen a lot easier than trying to multiply 16 and 5, which is why we talk about grouping. As you see over here, both answers are 80, so then that means that the way we group them doesn't necessarily affect the answer that we get. If you look on the bottom, we're going to practice doing this again. So if you look right here at our first one, it's 7 times 2 times 5. Now the way we want to group this is we want to put the 5 and 2 together because, again, that makes 10, which makes it then easier to multiply the 7, and that means we get 70. When you look down here, we've got 4, 25, and 3. Now I know this 25 kind of looks like a scary number, but I want us to take a look at the number we've got right here, which is 4. We know that each quarter is 25 cents, and it takes 4 quarters to get to $1, which is the same as 100. So an easy way to solve this problem when we group them is grouping the 25 and the 4, and we get the 100. Then we take that 100 times 3, which again is kind of like the 10, only we add an extra 0, so it then equals 300. If you take a look at this page, we've got a couple different shapes over here. And these 3 octagons are all the same for the fact that they all have 8 sides, 8 corners, and that they are flat and closed. That is a big important thing, is that they are a closed figure. These are different though because this one kind of looks like the standard size. This one right here is more flat and this one right here is smaller. So a regular octagon has all sides the same length and all angles the same size. So we're going to circle the octagon that looks like the normal octagon, which would happen to be this one right here. Okay? Suppose you turn a figure 90 degrees to the right, but it doesn't look like the figure has moved at all. Then the figure has turn symmetry. So turn symmetry, again, is when that you flip a figure or turn it or rotate it and it still looks the same. So when we look at these examples right there, when we look at these examples right here, we can see that there are a couple different examples. Let's start with this one. This one, it looks like they turned it, and it doesn't quite look the same because this one looks more vertical, while this one looks more horizontal. So that means it does not have turn symmetry. However, if we take a look at this next one, we see that this one starts at horizontal, they flip it, and then it becomes vertical. So again, this one does not have turn symmetry. But if we look at the top ones up here, there's that one and that one, we can see that they look the exact same, whether they flipped it, they rotated it, they turned it. So that means that they have turn symmetry. We are going to circle the one that has turn symmetry, which again is this right there. Okay? We're going to flip the page over, and I want you to take a look at this square right here. This is very important. This represents 1 cup. So if we go down here, we see that there's 2 squares right here, or there's a rectangle, but it fits 2 squares. So 1, 2. That means that 1 pint is equal to 2 cups, because again, one of those is equal to 1 cup. So that means if we can fit 2 of those, it's equal to 2 cups. If you look right here, this is what the pint looked like, this rectangular shape, but there's 2 of them again. Okay, so there's 2 pints. There's 1 pint right there, and we see that there's 2 of them right here. So 1 quart is equal to 2 pints. Quick question, if we were to split this in half to show cups, because again the cup is a little square up here, how many cups would it equal? 4 cups. It would equal 4 cups. So let's slide down the page a little bit. And let's remember that this is what 1 quart equals, this really big rectangular square. So then if we look right here, we've got this really big rectangular square which equals 1 quart, but there's another one. There's another quart right there. So 1/2 gallon is actually equal to 2 quarts. I'll move on to the side so you can see it. 2 quarts. Okay? Well, we've got this big, again, this big rectangular square. That's the best way I can explain it. And we're going to look down here and look, there's 4 of them. So that means a whole gallon, if a 1/2 gallon equals 2 quarts, how much would a whole gallon be? It would equal 4 quarts. Remember that capacity tells us how much a container can hold. So let's flip on to the back side and we'll quickly finish this up. Our word for today is expression. Expression means a way to name an amount. In math, it means a way to name an amount. So we're going to write that right here. And over here, we're going to give an example. I'm going to move this over just a little bit. Okay. An example of this would be the simplest expression for 8. Now, instead of writing out the word 8, which we could do, we could also just write that, which means 8. Okay. Another way to write this could be 4 plus 4, which we know equals 8. A third example could also be 4 times 2. Because both of these express the number 8. They give value to it. It is a way to name the amount. Okay? right. Let's look at the non-examples in the picture. So a non-example for this would be a triangle or a circle, because this is not a given amount. It is not a way to express amount. However, if we were to draw a picture to show an amount, so for example, 2 plus 2, we'll write 2 plus 2 right here under the picture square. We want to show a picture, and that's the point where the picture would actually express the amount. So let's just do 2 circles plus 2 circles, which we know equal 4 circles. But we have assigned an amount to these objects, which makes it an expression. That's how you figure that out.